초콜릿은 달콤해 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 오렌지는 상큼해 상큼해 상큼해.
Hi guys! Welcome back to my channel. I am Rose Vijoyce de Rosario, BBS Ed Math student from Kapalong College of Agriculture Sciences and Technology. So in this video, we're going to tackle about the derivation using different rules, which are constant rule, power rule, quotient rule, product rule, and lastly the chain rule. So let's go!
Let us define derivatives. So the essence of calculus is the derivative. The derivative is the instantaneous rate of change of a function with respect to one of its variables. This is equivalent to finding the slope of the tangent line to the function of a point. There are 5 different rules in derivatives: the constant rule, power rule, product rule, quotient rule, and chain rule. First, let us talk about constant rule. The rule for differentiating constant functions is called the constant rule. It states that the derivative of a constant function is 0. That is, since a constant function is a horizontal line, the slope or the rate of change of a constant function is 0.
So example for our constant rule. D over dxc is equal to 0, which is c is equal to any constant number. So we assume that our c is 9. So d over dx, 9 is equal to 0. F of x is equal to 9 and f prime of x is equal to 0. So we prove that this equation is true using the definition of the derivative. So f prime of x is equal to limit as h approaches to 0, f times x plus h minus f of x over h. So we know that the value of our f of x is equal to 9. So what is the value of our f times x plus h? So whenever we see x, we replace it by f times x plus h. So we do not have any x over here. So we assume that this is substituted by 9. So limit as x approaches to 0, 9 minus 9 over h. So limit as h approaches to 0, 0 over h is equal to 0. So this proves that our equation here is correct.
Another rule is the power rule. So the power rule in calculus is a fairly simple rule that helps you find the derivative of a variable raised to a power, such as x to the power of 5, 2x to the power of g, 3x to the power of negative 3, or 5x to the power of 1/2. All you do is take the exponent, multiply it by the coefficient, or the number in front of the x, and decrease the exponent by 1.
Example for power rule. So f of x is equal to x over n, where n is any constant number. So f prime of x is equals to n times x to the power of n minus 1. So we let that our n is equal to 9. So f of x is equal to x to the power of 9. So our f prime of x is equal to 9x to the power of 9 minus 1. So it derives into 9x to the power of 8.
Next is product rule. So what is the product rule? The product rule says that the derivative of a product of two functions is the first function times the derivative of the second function plus the second function times the derivative of the first function.
Example for our product rule. So this rule says that the derivatives of f times g is equal to f prime times g plus f times g prime. So we let that function f is equal to 5x minus 6x cubed and function g is equal to 21 plus x squared. So let's derive our function f. 5x minus 6x cubed using power rule. So it will come up into f prime is equal to 5 minus 18 x squared. So let's proceed to our function g. G is equal to 21 plus x squared. So there is constant, so we will use constant rule for this. And power rule for this. So it come up into g prime is equal to 0 plus 2x. So our g prime is 2x. So our derivatives of f times g is equal to 5 minus 18x squared times 21 plus x squared plus 5x minus 6 cubed times 2x.
Next is the quotient rule. The quotient rule says that the derivative of a quotient is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator.
Quotient rule. So this rule says that the derivatives of f over g is equal to gf prime minus fg prime over g squared. So here is our application. D over dx x squared over x minus 9. So let us derive this function. So function f is equal to x squared, so it will become f prime is equal to 2x. Then this g is equal to x minus 9, and it will become g prime is equal to 1. So let us substitute our values on this form. So it will come up into derivatives of x squared over x minus 9 is equal to 9 minus x times 2 minus x squared times 1 all over x minus 9 squared. So let us simplify this one. 2x squared minus 18 minus x squared all over x minus 9 squared. So let us go to the final answer, which is x squared minus 18x over x minus 9 squared. It can be factored out, so it will become x times x minus 18 over x minus 9 squared. So either of the two answer is acceptable.
The last rule is the chain rule. The chain rule states that the derivative of composite function of f of g of x is f prime of g of x times g prime of x. In other words, it helps us differentiate composite functions. For example, sin x squared is a composite function because it can be constructed as f of g of x for f of x is equal to sin x and g of x is equal to x squared.
Our last rule is the chain rule. So this rule says that the derivatives of composite function of g of x is equal to f prime of g of x times g prime of x. So here is our application. derivatives of 9x plus 7 raised to the power of 7 is equal to 7, which is coming from this power, and copy the 9x plus 7, and then this 6 is coming from 7 minus 1, and then the inside derivatives. So let us multiply this both 7 times 9, and then copy 9x plus 7 raised to the power of 6. So 7 times 9 is equal to 63, and then copy 9x plus 7 raised to the power of 6. So here is our final answer. So that's all for this video. Thank you for watching, and don't forget to like and subscribe. See you in the next video.